Okay, number 1 and 2 both are from section 4.1. I see that they're in standard form. And standard form is where I start with the AOS. Notice it tells you to start with the AOS in both of those, and we use that formula, negative b over 2a, that x equals negative b over 2a. So on number 1, I see that a is negative 1. So it's that number, the coefficient in front of x squared. The b is the number in front of the x, so that's negative 6. And c, which it doesn't ask us for in the formula, but that's that constant, the one that doesn't have a variable, negative 4. So x equals negative b. b is a negative 6. That's a negative 6, which is going to become positive. Over 2 times a is negative 1. I'm going to run out of room here, but I get positive 6 over negative 2. 6 divided by negative 2 is negative 3. That's the number that's going to go in the middle of my table of values. And it is part of my vertex. To get the other part of it, you plug the negative 3 into the equation. Be careful here. Some of you may make the mistake of squaring this negative. This negative, basically you can think of this as negative 1 times x squared. So negative 1, let me move over here. Negative 1 times your x right now being negative 3, squared, minus 6 times the negative 3, minus the 4. Order of operations says you square before you multiply. You have to square negative 3. Negative 3 squared is positive 9. So I really get negative 1 times positive 9. At that point, negative 1 times 9 is negative 9. Negative 6 times negative 3 is positive 18. And then negative 4. So negative 9 plus 18 is 9. Minus the 4 is 5. So I've got my vertex now, negative 3, 5. And now I want to surround it. So to the right of negative 3 is negative 2, and then negative 1. To the left of negative 3 is negative 4, and then negative 5. So I start plugging in. Maybe I'd start with negative 1. I don't want to fill up the whole paper, so I'm going to do a little bit shorter version than what I did on the first one. But I kind of follow the same pattern. I plug in a negative 1 instead of negative 3. So it says to take negative 1 and square it. That becomes positive 1, and there's still that negative 1 times that. So negative 1 times positive 1 is negative 1. Then it says to take the negative minus 6, says minus 6 times negative 1. Negative 6 times negative 1 is positive 6, so it becomes plus 6. And then it says minus 4. So I get 1. So that's what I'll get when I plug in negative 5 also. So then plug in negative 2. Square negative 2, that's positive 4. Negative 1 times positive 4 is negative 4. Then negative 6 times negative 2, that's positive 12. Then minus 4. For a total of 4. Now go ahead and put those on the graph. 1, 2, 3, 4, 5, 1. Now the graph's kind of small, but hopefully you can see it. Negative 4, 4. And negative 3, 5. Okay, connect to your dots for your parabola. Number 2. It's also standard form, so I'm doing the negative b over 2a again. A is 4, b is 8, c is negative 3. So negative b, negative 8, over 2 times a being 4. So I get negative 8 over, and that becomes positive 8. Together that's negative 1. So that negative 1 goes in the middle of my table of values. Plug it in, square negative 1. Let's see, I'll do it up here. So 4 times negative 1 squared plus 8 times negative 1 minus the 3. Square negative 1, we get positive 1. 4 times 1 is 4. 8 times negative 1 is minus 8. Minus 3 So 4 minus 8 is negative 4, minus 3 is negative 7. So negative 1, negative 7 is my vertex. Surround negative 1. To the right I get 0 and 1. To the left I get negative 2 and negative 3. It's easy to plug in 0. When I plug in 0, I get 0 plus 0, because 4 times 0 squared is 0, 8 times 0 is 0, and then you get minus 3. So 0 plus 0 minus 3 is negative 3. So I also get that negative 3 when I plug in negative 2. Now plug in 1, positive 1. 4 times 1 squared. So that means 4 times 1, which is 4, plus 8 times 1, which is 8, minus 3. So 4 plus 8 is 12, minus 3 is 9. So 1, 9, 7, 8, 9, and negative 1, negative 2, negative 3, 9 also. 0, negative 3, and negative 2, negative 3, and then negative 1, negative 7. 1, 2, 3, 4, 5, 6, 7. Connect the dots. That one's pretty steep. Okay, now when we move on to numbers 3 and 4, this is vertex form, which is actually section 4.7. Vertex form is 4.7. We'd find the vertex first. That's the HK. When the parentheses says x minus 4, I know I do the opposite sign, so negative 4. K is the constant, and at the end, don't change its sign. So negative 4, 4 is my vertex. So I plug that in the middle of my table of values. Then you're going to surround negative 4. To the right, you go negative 3, negative 2. To the left, I go negative 5, negative 6. So let's start plugging in. Let's plug in negative 2. This negative, you might want to think of that as negative 1 times. So plug in a negative 2. Negative 2 plus 4 squared, and then plus 4. Order of operations tells us we should simplify the parentheses first. So do the negative 2 plus 4, which is 2. Then square it. 2 squared. Don't do multiplication first. Do square first. 2 squared is 4. Now multiply. Negative 1 times 4 is negative 4. Plus the 4, now you get 0. So that's what I'll get when I plug in negative 6 also. Then I plug in negative 3. Once again, I don't want to take up as much room, so I'm going to do a little shorter version of it. So plug in negative 3. Negative 3 plus 4 is 1. I will have to square that. When you square 1, you get 1. Multiply by negative 1 is negative 1 plus 4, I just get 3. So let's go ahead and graph negative 2, 0, and then negative 3, 4, 5, negative 6, 0, negative 5, 3, and negative 3, 3, and negative 4, 4. Connect the dots, and done. Okay, number 4. Vertex, opposite of negative 1 is positive 1, and negative 6. Surround 1 with 2 and 3, 0 and negative 1. I might, let's see, I might plug in 2. A lot of times I plug in 0, but it doesn't work quite as well here. So I might even plug in 2. So 3 times 2 minus 1 squared minus 6. 2 minus 1 is 1. 1 squared is 1. 3 times 1 is 3. 3 minus 6 is negative 3. So when I plugged in 2, I got negative 3. Let's plug in 3. 3 minus 1 is 7. I'm going to get a 2. Square that. It's 4. So it's 12 minus 6 is 6. So negative 1, 6, 1, 2, 3, 4, 5, 6, 2 and 3, 6, 0 is at negative 3, 2, negative 3, and then 1, negative 6, negative 4, negative 5, and negative 6. Connect the dots. And there we go. Now 5 and 6, that's section 4.8 because we have an inequality. We have to worry here about solid versus dashed, and we have to worry about where to shade. Starts off with the first two, like the first two problems, axis of symmetry. The negative b over 2a. A is negative 2, b is 8, c is negative 3. So negative b over 2 times negative 2, that's negative 4. Negative 8 divided by negative 4 is positive 2. So 2 goes in the middle for my vertex. I'm going to plug it in. Negative 2 times 2 squared plus 8 times 2 minus 3. 2 squared is 4. So I have negative 2 times 4. So negative 8 plus 16, which is 8, minus 3 is 5. So round 2, I go 3 and 4, 1 and 0. It's easy to plug in 0. 0, 0, negative 3. Is negative 3. And then I'll plug in 1. Negative 2 times 1 squared, which is just 1. Plus 8 times 1. Minus 3. So it's negative 2. Plus 8, which is 6. Minus 3 is 3. 0, negative 3. 4, negative 3. 1, 3. 3, 3. 2, 5. Now, this time, I've got my points, but before I graph it, pay attention to solid versus dashed. Look at the sign. It does have an equal to, so it will be solid. So go ahead and connect the dots. And now I have to figure out where to shade. Now, this time it looks like it might be a little dangerous potentially to pick 0, 0 because it's really close to my line. I can clearly see it's outside of the parabola because it doesn't touch the 0 until it gets down here. So that's above it. So it is okay to pick 0, 0. If you're a little nervous, pick something like 2, 0 because that's clearly inside. So I might just pick 2, 0 since 0, 0 is so close to the line itself. So I'm going to plug 2 in for x, plug 0 in for y. 0 is less than or equal to. So if I'm doing 2, 2 squared is 4. So negative 2 times 4 plus 2 times, or sorry, 8 times 2. Minus 3. So I get negative 8 plus 16 minus 3. Negative 8 plus 16 is 8, minus 3 is 5. So 0 is less than or equal to 5. That is a true statement. 0 is less than 5. 2, 0 is inside the parabola, and it was a solution, so all of my solutions are located inside the parabola, so shade inside. Okay, number 6. A is 1, B is negative 6, and C is 5. Negative B, so negative negative 6 becomes positive 6 over 2 times 1. 6 over 2 is 3. 3 goes in the middle of the order of the table. 3 squared minus 6 times 3 plus 5, that's 9 minus 18 plus 5. 9 minus 18 is negative 9 plus 5 is negative 4. So round 3, 4, 5, 2, 1. I'll plug in 1. 1 squared is 1 minus 6 times 1 is 6 plus 5, I get 0. So I get 0 when I plug in 5. Let's plug in 2. 2 squared is 4 minus 6 times 2 is 12 plus 5. I get negative 3. So 1, 0, 3, 4, 5, 0. 2, negative 3, 4, negative 3, 3, negative 4. Before you connect the dots, pay attention to the sign. The sign is less than, so it's not an equal to, so this one has to be a dashed line. So I need to test a point. Here would be okay to pick 0, 0, because I was at 1, 0, so 0, 0 is definitely outside. You know that for sure. So I get 0 is less than 0 plus 0 plus 5. So 0 is less than 5, that's a true statement. 0 is less than 5. 0, 0 is outside of the parabola, and it is a solution, so I should be shading everything outside of the parabola. All right, let's go to the back page. This first, so now this whole back page is section 4.2, the whole side. Finding solutions. The first 4 problems, look at the picture and identify them. So on number 7, you were just looking for the x-intercepts, there and there. So that's at negative 2, and negative 3, negative 4, negative 5, negative 6. So negative 2 and negative 6 are the answers. Number 8, it only touches the x-axis once, so there's only one answer. It touches it at 1, 2, 3, so x equals 3. Number 9, it never touches the x-axis. There is no real solution. There's actually imaginary solutions, and we learned about those earlier in the chapter, but in terms of graphing it, there were no x-intercepts, so we'll say there's no real solution. Number 10, there's 2 of them, there and there, so it looks like we get negative 2, and then 1, 2, 3, 4, 5. Negative 2 and 5. Okay, and those are setting me up for numbers 10 through 12, where I'll use the graphing calculator. So before I plug any of these in the graphing calculator, you need to make sure they're set equal to 0. I notice number 11 is already set equal to 0. That one's ready to go. Numbers 10 and 12 are not, though, so they take a little bit of work. So number 10, I want to move that 3. It's a positive 3, so to move it I have to subtract 3. So I get 2x squared plus x minus 3 equals 0. So I will type that into the calculator. Under my y equals 2x squared plus x minus 3. I will graph it. It looks like it touches probably a positive 1. This one looks like maybe it's like negative 1.5 or something. We can verify for sure what it is by going to this calc menu. It's in blue. Right above trace is where I'm pointing. So since it's in blue, I have to hit second first, second, and then hit that trace/calc button. Brings up this menu. I want the 0 option, the second one down. 0 is another name for x-intercept, so choose that. So hit enter. Now it asks me, you can see there in the bottom, it asks me left bound. So we have to identify, you can only find one x-intercept at a time. There's 2 of them. There's one over here, and there's one over here. Pick which one you're going to find first. So I'm going to go for the one on the left. So I need to move this flashing cursor to the left of that x-intercept. So as I travel further left, I'm just hitting the left arrow. It's getting closer, closer. Eventually it will pass it. I want to make sure I'm past it. Doesn't matter exactly how far, just sufficiently past. Then hit enter. Puts that dashed line there, and now it asks for the right bound. So now you have to move back to the right. Make sure you get past the x-axis, that x-intercept sufficiently. I'm past it now. Hit enter. Puts the blue line there. Notice that x-intercept is between the lines. That's what I want. Now it says guess. They want you to move your cursor back to your best guess. Somewhere around there. It doesn't have to be exact. You're just telling the calculator where to look, and then it tells you your answer right there in the bottom left-hand corner. It says that x is negative 1.5. Of course y is 0. Better be. I'm just looking at the x value. So x is negative 1.5 is one of my answers. So x equals negative 1.5. And then I can repeat the process to find the other one. So I go back to that calc function. So second calc, 0. left bound, but I've got to move over closer to that other x-intercept. So I am to the left of it now. Choose enter. Move further to the right for the right bound. And past it. Choose enter. Go back and guess. And it says our x is 1. So we get negative half, negative 1/2, and 1 as my answers. Number 11, it's already set equal to 0, so I'm ready to type that one in the calculator. So go to y equals, I'm going to clear out the equation that's there, type in x squared plus 10x, oops, wrong button, okay, 10x plus 25. Graph. Oh, looks like there's only one answer this time, and it looks like it's probably at negative 5. I'm going to use that 0 function to verify. Second, calc, 0. Left bound. I can't even see where it's at. I don't even see the flashing cursor. So look at the ordered pair on the bottom. It tells you where it's at right now. It's at 0, 25. So it's up here off the screen somewhere. So I know I need to travel left. So keep going left. Watch the number on the bottom of the screen. You can see it's getting lower, lower, lower. Soon I'm going to see the flashing cursor. There it is. So keep traveling left. Make sure you get past it. I got past it. So enter. Now move back to the right. Get past the intercept. Now go back and your best guess, about there. It will tell you your answer. Now it gave me a funky decimal. Sometimes it does that just a little bit off. We would call that negative 5. Negative 5.00003 is really negative 5. So x equals negative 5. Only one answer on that one. It's only touched it once. And then lastly, number 12. It's not set equal to 0. I need to subtract that x over because it was a positive. So I have a negative x squared minus x plus 12 equals 0. So we'll put that in the graphing calculator. Y equals, I'm going to clear, type it in negative, make sure not minus, but if you do a minus instead of negative, your calculator will not be happy with you. It will give you an error. Negative x squared, now minus, not negative, minus x plus 12. Graph that. Looks like we have two answers, about negative 4 and about 3. I'm going to verify them. Second, calc 0. I can't see it, but it's at 0.12, so it's up here off the screen. I want to travel further left. There it is. Travel to the left of that one. Enter. Travel to the right of it. Enter. Guess. It says x equals negative 4. And now, repeat, second, calc, 0. Left bound. So travel to the left of the 0, travel to the right of the 0, and give it your best guess, and we get 3. So I get negative 4 and 3. Alright, thanks for watching.